to our YouTube channel. We are starting a new series on MPI. And before this, we worked on OpenMP. Both of the softwares are quite similar to each other, as in they are both used for parallel programming, but they are subtly different from each other. So today we'll be studying about MPI, and without further ado, let's get right to it. So what exactly is MPI? MPI, or Message Passing Interface, is a widely used standard for writing parallel programs. But what makes it different from OpenMP that we recently studied? Well, MPI has the capability to connect multiple nodes together. So it was specially designed for that purpose. So in very large systems, like in supercomputers, we have multiple clusters which are connected via Ethernets or InfiniBand, as in the case of param rudra. And although they are connected, but to make the nodes work together to achieve a single task, that needs a specialized software. That is where MPI comes in. So how does MPI actually work? So if you remember, in OpenMP, we were creating multiple threads and using those to solve a problem. However, MPI, what it does, it splits the program into independent tasks. So in OpenMP, the threads were dependent on each other and they were sharing the same memory. But in MPI, what happens is the program gets split into independent processes. So each small part is called each single part of the main program is called a process in MPI. So it splits it into multiple processes, and each process works independent of the other, and the memory and the variables are not shared between them. So in OpenMP, we had to clearly specify that this variable needs not to be shared. It needs to be updated singularly. It does not need to be updated simultaneously. But in MPI, those problems do not occur because variables are not shared. Okay, so let's get right to a demo program of it. So as like always, everything in programming starts from hello world. So here also we are on the back to the same page. MPI. Okay, let's start from the top. Include MPI. So pretty basic. We are including the MPI module. And then here's the main change. We have int argc and char argv. So what exactly is this? They are arguments. What do I mean to say by arguments, and why do we require this, first of all? So these arguments allow MPI to take in runtime commands. So these can be filled in with runtime. So that is something we will talk about in the live demo section, in the live section. But for now, just keep in mind that these are required to give runtime commands. So when we are running the executable file after the compilation. So next is int rank. So I'm creating two variables with integer as their integer variables, rank and size, and MPI init, initializing MPI, and this is the standard statement. This is also because I'm just initializing MPI. So now we have MPI com rank. So communication, com means communication, and rank means I am taking in all of the ranks. So what I mean to say by rank is the process ID. That is the rank, and it starts from 0. So like in OpenMP, we had the thread ID. Similarly in MPI rank. So MPI com rank, so it will get the rank of each process. MPI com world, similarly, it's a standard statement. So Com rank, that means get the rank of the process. Com world specifies where I want to get the rank of. So I can create multiple communities. Yeah, I can create multiple communities in MPI. And com world means I want the rank in the entire world. So you can understand that. So every process that is running, I want the rank in that world. What's the hierarchy there? And I am creating a pointer here. So this is a pointer, and I'm creating it to int rank. So what I mean by that, I want to store the ranks of the processes in this variable called rank. And this is the MPI com size. So by size mean the number of the the number of processes that were initiated. And similarly, com world, that means I want the size of the entire world, not a single community. And size, I'm storing it, storing all the values of the size in the size variable. And this is the simple printf statement. Hello from process %d out of %d processes. So rank and size will be replaced here. And MPI finalized. So that means I want the MPI to end here. So let's move to a live demo. And this is the program that we'll be compiling for this demo. Okay, let's see. So I'm currently logged into a HPC param rudra, and I'm inside the login node right now. So first of all, to run the MPI programs, I need to load a certain module. So I will just type module load and then open MPI. Open MPI is the software, is the provider for this. And I'll just do it like this. So this is the version of the module that I want to load. Yeah, so now I have the module. I can compile the program. MPI C++. So since it's a C++ program, I need this MPI hello world.c. Program is compiled. And now the part where I said, remember I said we need a, yeah. So we need this statement, need these arguments to give runtime commands to MPI. So how can why do I need that? Because when I try to run MPI, I do not have to simply write /a out, a dot out. It does not work that way in MPI. I have to write this statement, MPI run -MP4. That means number of processes, how many do I need, and then the executable, which will be /a out. Yeah, there are a lot of warnings. We can ignore them. And I have received so 0, 1, 2, and 3 out of 4 processes. It has given me the output. Similarly, I can change the number of processes from here. Let's not do 46. That will be a little too big. So 6. Hello from 2, 4, 8. So you can see, notice one thing, there is no order between the number of processes. And the reason is same. Some processes finish first compared to the others, and that is why this happens. So that is it for this video. Thank you. In the next one, we'll be talking about how we can share data between these processes. Thank you for watching.